It gives me the greatest pleasure to introduce our next guest speaker, Dr. Carole Sharabati, founding partners of Siren Analytics. Carole has 25 years of professional experience in research, teaching, consulting, technology, communication, and management. She currently holds the position of Professor of Political Science at the University, Saint Joseph University, USG, where she teaches various courses in political science and quantitative method. In addition to her academic work, Carole also served as the Director of Research at Siren's Associates, a prominent public sector consultancy firm boasting a team of 150-plus consultants, experts, data scientists, and engineers. She is also the co-founder of CME Offshore, a multinational technology firm with 350-plus engineers in Lebanon and over 200-plus engineers located internationally in the US, Argentina, China, India, Dubai, and Europe. Carole earned her PhD in political science and quantitative method from Claremont Graduate University in California. Today, Carole will be speaking about how transforming the public sector with technology and AI. She will explore how technology and data-driven decision-making can propel public sector reform. She will share a real-world example of how data modeling has transformed administrations and institutions in the security, governance, and media sectors in Lebanon. Through these case studies, she will demonstrate how technology and data modeling can help to foster a new social contract, one that prioritizes accountability and transparency in the public sector. So please welcome with me Dr. Carole Sharabati. Carole, the floor is yours.
Thank you. Hello. I'm going to talk about Lebanon. I'm going to share 4 stories, 4 experiences in Lebanon in 4 different sectors where AI has been used, has been digested by the users, by the champions of change, and it has brought some interesting results. So let me tell you some of these stories. I'll cover 4 areas. One is related to the security sector. The other one is related to building civic culture and detecting fraud. The third one is about aid distribution. And the 4th one is about journalism and fake news. So let's take a look at the big picture. I picked these 4 cases because each one tackles the reform and change in Lebanon from an angle. The first one tackles reform from an institutional angle. And here we have a problem in Lebanon, which is we have weak institutions. Our institutions are not necessarily efficiently providing the services they need to provide or operating. And here the experience was with the security sector, where we developed intelligence-led policing and different analytical tools, including hotspot analysis, to optimize and develop and increase safety among communities. The second case is a case related to services and policy decisions. This is a case related to aid distribution. You know that in Lebanon we have rampant clientelism and we have favoritism. And whenever there's money to give away, it's not going to be given away to those who need it. It's going to be given away to those who have access, have WASTA, etc. So the whole idea was when the World Bank wanted to distribute the $250 million to the ESSN program, the whole idea was to create a system that can provide fair distribution. And here technology was used to disseminate the aid to the people who are in need, the extreme poor family households, and to address the clientelism and risk of favoritism and reach fair aid distribution. The third one, because at the end of the day we have the institutional aspect, we have the policy aspect, but there is also the people aspect. In Lebanon, corruption is also within the citizen, within the behavior and the culture. So this was a funny experience during the lockdown when you guys were taking your permit to go out. Many of you tried to cheat. and we caught you. So I'm going to tell you how. And the first one is a very important one, which I discovered. It's related to media. Media has a big role in the country. No matter what you do, if we don't talk about things truthfully, it can be messed up and it can lose its value and its impact. So we worked on fake news detection in the Arabic language, and I'm going to tell you what we did to develop a tool that helps fight disinformation and misinformation. So these are the 4 stories that I'm going to share with you one by one. So let's start with safety. I've been working a lot in the security sector with the police, but at the end, the police is just an institution providing services to the citizens. And what was interesting here is to move with the police from an institution that has these big Ottoman, notebooks where they write things, to a system, a police where there are systems that collect data and that connect different units, that connect command and control centers with police stations, with headquarters, with patrols, with staff in the ground, and where data can flow and where information can be shared. Now, different kind of information can be shared, but in the heart of information sharing here is information about incidents and crime. If only incidents and crime were reported regularly and their location and date is reported, you can already do a lot. So we started with that. And once the system was deployed to collect the data, because in Lebanon you have to generate the data to generate the AI afterwards. So you have to start by doing that. So once this is done, we started to work with them on intelligence-led policing, strategic, tactical assessment, problem profile. Many tools are used in those analyses, but one interesting tool is the analysis of space and time clusters of crime and incidents so that you can locate hotspots, you can locate peak times, and automatically this allows you to disseminate your patrols to the right place at the right moment to prevent crime. So what happens is you change the police from a reactive police to a preventive police. So you develop a police that kind of prevents crimes and operates in a way that's much more efficient and saves some of its resources in fighting crime. So this is the first story. The story was a very interesting one because over 2 years period, we have seen some decrease in crime. You can see 2017, 2018, there was about a decrease of 30% in crime because they started to work on their decisions, on their patrols, on their strategies on the ground in order to tackle crime in a more intelligent and not in an ad hoc way. And this is a very good example about decision-making in our institutions. If our institutions start to rely on data to make their decision to tackle the problem with a more articulate methodology, then they can gain a lot. Here comes the second example. This is the one where you were cheating. This was during the lockdown. You remember Impact, where everybody had to take a permit, you were locked at home, you had to take a permit, to take a permission to go out. And in the system, there were length of permits. Yani, when you were going to the pharmacy, you were given a half-an-hour permit. When you're going to the hospital, you were given a 4-hour permit, etc. People started to play by the rule. They started to joke, but then they started to play by the rule. But once they discovered the rule and the system, they started to cheat on the system. So as people started to take permit for the wrong reason, to do the right thing, etc. Everybody was going to the hospital on Sundays. So here we go, all of a sudden, week after week, the Sunday hospital visits started to increase. Something had to be done. And there's a huge amount of data here. There's about 1 million requests that were taken per day, sometimes more. Sometimes there were peak at times where they were much beyond. So the idea was to develop a system to detect fraud. And here we used isolation forest to do something very interesting, which I'm going to show you live. I'm going to show you actually in a dynamic way. We took 14 days time span for human beings taking permits, and analyzed the patterns of the behavior. Because people were saying where they live, where they're going, from where they're leaving, how they're going, if they're going by car, by walking, etc. And as you analyze patterns, gradually, some people are going to look alike, and they're going to look like a normal social pattern, and some people are going to look like an anomaly and like outliers. So we used this algorithm to detect the outliers and detect the normal patterns and classify them. So you can see here in this graph, you have the blue dots are those who are socially normal behavior, and this is where the bulk of the data is. But then when you look at the red, these are people who are more outliers, and their behavior is not very normal. It's the person like that goes 3 times to the hospital on Sunday, right? So you can see it, and it's interesting because as this classifier has classified the data, you can see how it really looks. You have the social normal behavior here, and you have all the outliers here, which to a certain extent allow us to detect the risk of a fraud for certain cases. So this was an interesting example. Now, a good learned lesson from this case also is that you can detect fraud. Patterns of behavior are interesting and can detect fraud. So when people try to cheat on the system, you can embed into the system something that helps detect them. But when you're working in COVID, time will unfold very fast. So by the time you roll out your system fraud detector, the lockdown is almost over, and it's a bit, so it was a bit a race of time. We gained only a couple of days on the system to block people. So if you were not able to go at the last weekend, on the last Sunday to the beach, you know who to blame. Third story, well, this is a really critical one. And this was a very interesting story. And somebody I have had a long adventure in the story here, Hanin, is here in the room. So this is a project we worked with the World Bank. It was about distributing aid to the poorest family, the extreme poor households. What is critical about this is that the program, the World Bank wanted to roll out the program 6 months before the elections. And you know, in the elections, 6 months before the election, there's a market. You know, where you can buy and sell anything and everything and get votes in return. So all of a sudden, you want to distribute this aid at a time where it's really sensitive, and the political will is to divert this aid to buying vote, etc. So what was done here is the deployment of a fully digitized system where people could register, they receive visit, the data gets verified, and then the poverty indicator is computed on the system so that they can be selected to receive a payment or not to receive a payment. So what was used on the system is what is called the proxy means test. It's a method that's used by the World Bank in many of the programs and many other programs also. It's a very simple method. What it does, it collects first statistics about the society, about consumption, and socioeconomic characteristic, which are the proxies of every household. Then a regression or a similar model to the regression is put in place to correlate the two, and systematically you have predictive model. So you know in this population what is the impact of these proxies on the revenue or the expenditure of the household. So next time you have a household, you know the socioeconomic characteristic of this household, you can predict what would have been their revenue or expenditure. So proxy mean test was used on the system to classify household, whether they should be a recipient of aid or not recipient of aid. 80,000 households, 550 households registered on the system. 250,000 were visited to verify the data. 80,000 were selected by the system and are still getting, in 2 days they will get their next monthly payment from the system after being selected through the proxy mean test. What is very interesting here is that there has been zero arbitrary decision, no WASTA, no intervention, It has not interfered in the election. It has run smoothly. And people that nobody know, nobody see, they ask no one, ended up receiving their payment on a monthly basis. Students went roaming in the street to assess and do some statistics to evaluate how did the population perceive this and whether the poorest household were really targeted or not. And some of the numbers were interesting. Like one of the interesting numbers is that from the calculation of their survey, on average, $29 a month is the per capita revenue, which is an indicator that we really targeted the poor family. Those that were that have disability within their family were more likely to be selected. Those that have a higher number of dependencies, yani older and kids, were also more likely to be selected. So we had some indicators through the student survey that the system did work. And here comes the fourth story. And this is actually my favorite. The story came after when we were rolling all these projects, we learned how important the impact of the media is. Because no matter what you do, the media can talk about it differently. And the whole misinformation can flip the whole story and turn things around. So we started to work on media and communication. And we deployed a system because today there are many groups of fact checkers around the region in different Arab countries that verify media and verify news, whether to see whether they're truthful or not. So we deployed a system called Dalil that allows these fact checkers to verify the visuals and the text on the media. I'm going to talk about the text. I'll put the visual aside. So those fact checkers, they take any article, they put it on Dalil. There's an AI system that will scan the article and that will tell them if the article has bias in it, if the article has propaganda in it, and what is the extent of corroboration of this article in the net in general. So this system was built on Arabird. Arabird is built on Bird. It was built by students in AUB here, Wissam Antoun and Fadi Bali. We used Arabird to build on it the Dalil system. So Arabird takes the text, scans it, and gives you the extent of bias and propaganda in the Arabic language in the text. What is interesting here is, okay, you can take a text and scan it. What does it mean? It means that if you find a way to scan all the text in any media at all times, in real time, you can have an index that tells you the level of bias and the level of propaganda by media, by journalists. Beautiful. If you can put this up, you can intimidate them. So we have not gone all the way to publish the data yet, but we did some exercises, and I didn't put the name of the newspapers. I'll let you guess. But there is a red and a blue. So newspaper X, for instance, had 33% bias, 17% propaganda. That's the percentage of the sentences in their articles. Whereas newspaper Y had 20% bias and 11% propaganda. So this is an interesting thing that can help us develop a system where we can intimidate or provide some kind of neutrality or truthful reporting index for media and journalists. But we can do even more than this. We can develop, and this is where we're looking now, a turn it out. You know, many of you are probably academics. You know, you have turn it in. Your students, they put their reports on turn it in to see if they're plagiarism. Well, turn it out is the same thing for journalists. They will put their article on the system, and the system will tell them if there is bias and propaganda, and it will highlight the sections for them. So we will help them go and fix their article before they put it out, so that we don't name and shame in our indexing. So this is, the Turnitin part is not out yet, but it's under construction. And within a couple of months, it should be out. So this is my story, 4 cases. They're different. But what's interesting is the relation between them, because they show that in our country, we can introduce technology from the different angles to build our own theory of change, from the institutional angle, from the citizen angle, from the policy decision angle, from a civil society, because this is where media belong at the end angle, and that things can happen. Lebanon is a country, is today a low resource country, and one may think that AI are done only for high resource or when you have the capabilities, etc. No, it does work, and it's actually badly needed, and this is where it should be going the fastest we can.
We have time to take 2 questions, only 2 questions, because we're running out of time. So are there any questions, please? Yes, Imad, always Imad.
Hi. It's been a while we didn't meet. Actually, there are very interesting examples that you presented where you can use AI or analytics. Just I have like a comment and a question regarding the slide that you showed about the permission during COVID-19. Can we just see it again? Okay. So here the blue ones were the normal, or that they follow the rules, and the red ones are
are the
outliers.
anomalies.
So at the first view that we can observe like that the outliers are much more than those that are regular, right?
Actually, no, the outliers, the bubbles are not proportional, but if you see, here you have thousands, the outliers are much less. It's actually 10%.
Mm-hmm.
Okay.
10%.
So we put the 10% threshold.
So have you tried to compare those results with another country to see if there is any cultural effect?
No, it's a good idea.
Yeah, no, exactly.
It's
so
a good idea.
if we can have like data from another country to see if this is really a culture or maybe this is like a human being nature in general.
It's a good idea.
Okay. So you didn't do this comparison?
No. But yeah, comparative statics is one of the way to verify the validity of what we have and to understand more what's going on.
Okay, thank
But
you.
You need to find similar data in other countries. It's not.
Yeah.
It's not.
So I will leave the floor to someone else to ask the second question.
Look, Wissam, you can do something. You can compare between regions if you want. Like urban, rural, remote, dense, not dense, and see. But I'm not sure what will come out of this. Yeah.
Hello. Thank you very much for the presentation. I would just like to add, to ask, please, regarding the journalism project, who put the rules that they were founded on? I mean, decide whether a newspaper is biased or there's propaganda or anything.
So we've used 3 types of labeling. A first type of labeling, we've taken open source data labeled in English that we have translated into Arabic and used it. The second source of labeling, we put our own methodology and went and did some labeling through ChatGPT. And we produced thousands of labels that we also tested. And then we did some human labeling as well to check what's going on.
Oh, okay.
And some things work better in one methodology than the other. So ChatGPT worked better on subjectivity, less good on bias, breaking down also breaking down the propaganda into different types of propaganda can also help you understand what's going on and what works and what doesn't work and what type of labeling works better. Propaganda was broken down into 5 types of propaganda: exaggeration, minimization, repetition, doubt, and name calling.
Wow.
So, yeah. But
So
3 types of labeling.
And eventually you did apply it to other newspapers, to foreign newspapers other than Lebanese? Did you apply it to other newspapers other than Lebanese newspapers?
Actually, here I had the example for 2 newspapers, but the test was done across different newspapers, across the MENA region in Arabic.
Thank you so much.
So across countries, but all in Arabic.
I have a question regarding the third scenario. I work at a non-profit organization, and you mentioned that you distributed the aid through a fully digitized system, where the beneficiaries fill their information, and it was a sensitive data. So I want to ask you, how do you guarantee that this data is correct? And in some cases, the beneficiaries themselves refuse to fill such data because they consider it sensitive. So how do you tackle this?
Very good question, actually, because the first, the second, and the third projects are actually government projects. It's the government who distributed data, it's the government who's deploying patrols, and the question is, this was one of our biggest challenge, you know, and it's the biggest challenge of all the data analysts on the project. How do you do the data analysis on data that is confidential, sensitive, and is owned by the government? I'll give you what we did on the World Bank project, because here you have the National Poverty Targeting Program that needs to do its analysis, you have the Ministry of Social Affairs that needs to do analysis, you have the World Bank experts, you have the WFP experts who were also working on the project who need to do analysis. So what is done is we created a kind of what we called a closed playground. So we created an environment where there is an anonymized data, but where you cannot take the data out, where you have all the Python and, you know, the SPSS and the Stata tools deployed, and where the data analyst can go in and analyze but cannot take anything out. And this was the best way for us to really resolve the problem of, you know, reconciling the privacy and at the same time the research and the need for analysis. So that's how you do it. So it has to be done on the system in a way that is protected, and then there is always an anonymization stage that's being done, but also you keep it in a relatively closed environment. Now, until Lebanon has some rules that can also facilitate maybe the sharing by the government of anonymized data, but it does not have today. So the best way was to play it in a very conservative way and anonymize plus put them in a closed playground on the government service.
Thank you, Carole. Thank you so much. Please, if you have more questions, you'll have the chance to network with Carole, Rima, and our prestigious speaker during lunch.